Geoengineering. Sorry, have you started? Okay, sorry. Sorry. 3, 2, 1, go. Geoengineering, a positive action in the face of no action. We just reached 400 parts per million of carbon dioxide in the atmosphere at Barring Head Clean Air Institute in Wellington. A higher concentration of carbon dioxide in the atmosphere means that by the end of the century, we will have anywhere from a 2 to 6 degrees Celsius temperature increase. This is because carbon dioxide is a greenhouse gas and traps the sun's heat in our atmosphere. Carbon dioxide is released into the atmosphere when we extract and burn fossil fuels or when we clear forests. The more carbon dioxide in the atmosphere, the hotter our planet gets. Even if we curb our emissions by 90% of 2006 levels by the end of the century, the planet's temperature carries on warming for many more years. A New Zealand with higher temperatures will have higher sea levels, leading to erosion of our coastlines and putting coastal settlements, farmland and roads at risk. We will have more extreme weather, resulting in more floods and higher insurance premiums. Not to mention that our seas will be more acidic, putting marine ecosystems at risk along with our seafood and tourism industries. No sector of New Zealand industry will be unaffected from global warming. None of your lives will be unaffected either. Current efforts to stop climate change through mitigation and adaptation are not happening fast enough. Due to the delay in action, geoengineering has now become feasible. Geoengineering means any attempt to rebalance Earth's climate through direct, large-scale human change to the planet's land, oceans, or atmosphere. Think of geoengineering as a seatbelt. It increases the time of collision between Earth and the effects of climate change. This gives us more time to mitigate our emissions and adapt to the changes global warming brings to our everyday lives. There are two main types of geoengineering. Firstly, solar radiation management. This aims to reduce the amount of heat stored by greenhouse gases in our atmosphere by reflecting sunlight back into space. The other options, carbon dioxide removal, aims to absorb and store carbon dioxide from the atmosphere. So there are many methods of solar radiation management. Some of these include albedo enhancement, which is basically increasing the reflectivity of the Earth's surface, including plants or clouds in order to reflect more of the sun's light and heat into space. We could also put space reflectors that block a small amount of sunlight before it reaches Earth, just like that, out there. We can investigate stratospheric aerosols, where small reflective particles are introduced into the upper atmosphere to reflect sunlight before it reaches the surface of the Earth and therefore prevent warming. In the second category, carbon dioxide removal techniques include afforestation or reforestation. It may seem obvious, but planting trees removes carbon dioxide from the atmosphere. You can make biochar, which is a charcoal made out of organic matter. This charcoal can be buried so that its carbon is locked up in the soil, reducing carbon dioxide in the atmosphere. An exciting area of research is carbon capture and storage, which is when you grow and gather biomass, i.e. trees, garbage, landfill, which is when you grow and gather biomass, i.e. trees, garbage, landfill, gas, and burn it to create energy, and capturing and storing the carbon dioxide created in the process. You can also develop artificial trees. This would be large machines that can remove carbon dioxide directly from the air and store it elsewhere. Ocean fertilisation is another interesting technique, adding nutrients to the ocean in a selected location to increase the production of phytoplankton, which draws down carbon dioxide from the atmosphere by photosynthesis. Artificial weathering works by exposing large areas of quantities of minerals that will react with the carbon dioxide in the atmosphere and storing the resulting compound in the ocean or soil. Lastly, ocean alkalinity enhancement. The ocean is already slightly alkaline, so what you want to do is restore this or offset the acidity caused by increased carbon dioxide in the water. By grinding up, dispersing and dissolving rocks such as limestone, silicates or calcium hydroxide in the ocean, we can increase its pH and thus increase its ability to store carbon and directly counterbalance ocean acidification. Oh, sorry. The benefits of some geoengineering options in New Zealand are: if we select or engineer crops and grasses with high reflectivity, we can offset the temperature increase that occurs as a result of our agriculture emissions. Also, if we take biochar out of our forestry and farm waste, if we make biochar out of our forestry and farm waste, we can store carbon in the ground, which otherwise would have ended up in the atmosphere. We can also use biochar as a fertiliser, and this would lead to less emissions from fertiliser manufacture in New Zealand. New Zealand is surrounded by water, so it is in a great position to research into cloud reflectivity enhancement. Our clouds already reflect more of the sun's radiation back into space than the amount trapped by human emissions of carbon dioxide. So why not make our clouds even more effective? If we can find an affordable, complication-free way of doing this, we will be leaders in this new, exciting field. Geoengineering is controversial because it is global, and a lot of people are worried that geoengineering techniques will be used as weapons or political tools. New Zealand is in a unique situation as it is fairly independent to the rest of the world, and it could create legislation in order to become a world leader in the field of researching geoengineering. Not only could researching this field help offset or help decrease our emissions, it will give us time to solve climate change issues and put New Zealand forward as leaders in geoengineering. The longer we wait for worldwide unity and agreements to stop climate change, the more likely we will reach temperature increases that will result in catastrophic changes to our planet. To stop these catastrophic changes, we may have to use large-scale geoengineering techniques. If we research these techniques now and understand their consequences, then we are more likely to save the planet when we have no choice but to use them. Geoengineering is a positive action in the face of no action.